Let's continue with our general best practices guidelines. Casting is one of those things that can get you into trouble. Try to use is and as instead of doing a cast. In that first line, we have a customer object, and we're trying to cast a user into that customer class. That can throw an exception, obviously, if user cannot be cast. What we'd like to do instead is to say if user is customer, then set customer equal to the user as customer. The if obviously should protect this statement, but even if there is some problem in casting the user to a customer type object, the as will return a null as opposed to throwing an exception. And then you can handle that error later. As we'll see in a future lesson, exceptions are expensive and we'd like to avoid creating them. Using is and as is one way of doing that. Nullable types are a handy thing, particularly in mapping to database fields. And I'm not sure enough people actually are aware of them or know how to use them. So I thought I'd put that in here. So in this example, we have a nullable integer, as denoted by that question mark after the int type. You can also use a nullable keyword as well. So we have a nullable integer for our customer ID, and I set it equal to null. And then we do some code, and then we check an if statement. And if the customer ID dot has value, which indicates that the value is not null, we'll get the value, and that will be the value of our customer ID, an integer value. Obviously, the else on this would indicate the customer ID is null. And this is one of the keys in dealing with nullable types, is using has value and value, because you can get in a lot of trouble if you just assume that a nullable type does have a value. You can get a lot of null exceptions if you don't check has value. The using keyword manages object disposal. So in that first part, we've got using my class is equal to some new class, and then we use that my class. And when we close the curly brace for the using statement, my class is disposed, which means it actually calls the dispose method on my class, so the resources of my class are cleaned up. It's the rough equivalent of what you see below in using my class is equal to new my class, and put it in a try, and then use a finally to call dispose. Now, of course, there's no exception handler in this try, so we're not exactly trying to catch any problems. We just have a finally that's calling the dispose. And that's why this is roughly equivalent to the using, which is definitely much cleaner code. Of course, if you need to catch exceptions, then the try catch finally pattern is what you should use. Speaking of using, it's good to implement iDisposable in your classes, and that will mean that you'll implement a dispose method. And in that method, of course, you want to free any resources that your classes have used. Implementing iDisposable in your classes allows any client classes that are using your classes to use a using block. So again, it can have a using my class is equal to a new my class, and at the end of those curly braces, your class's dispose method will be called. So implementing iDisposable is a nice courtesy to any client classes that are going to use your class. Of course, if you don't have any resources that you're going to dispose, it's completely unnecessary. But if you do have resources, like connection objects that you need to dispose or close, or perhaps file objects that you need to close, or streams, then you should implement iDisposable. Let's talk about collections for a little bit. Selecting the right type of collection to be used can be a little bit of a challenge sometimes. So here are a few guidelines to give you something to think about. Use list when you're iterating through a collection. So this is when you're going through a collection sequentially, and that's the way you want to approach it. The contains method in list is really slow. So if you're kind of doing a random access or a search, then a list is really slow, and you don't want to use that kind of collection for that type. List is really good, however, for iterations. It's much quicker than the other kinds of collections. If you are going to use contains, then maybe take a look at a hash set instead. The contains method in a hash set is tremendously faster than the contains method in a list. The downside of a hash set, of course, is that there's no defined order. So you can put objects into a hash set in order 1, 2, 3, 4, but there's no guarantee that they're going to come out in that order. So truly, you need to access a hash set by its key. You can use sorted set for ordered lists, and that also has a more performant contains method than a generic list. It's also preferable to use collections rather than arrays in a lot of cases. And the reason is you have more control over the contents of your collections because you're going to be able to use add and remove methods without having to reallocate arrays, and because you also have contains methods as well. So collections are more flexible and usable as your application adapts. It's a real pain if you've started off with an array and some feature requirement change for your application makes you go to a different kind of collection type, and you have to rewrite all of that code that accesses the array. So starting off with a collection is often a better choice just in terms of that maintainability for growth. There are times, however, that arrays are a good choice. Arrays minimize memory consumption simply because they don't have the overhead that collections do. And byte arrays are often required. For instance, when you're working with stream objects, you're going to be working with byte arrays as opposed to collections. And collections of bytes are not particularly performant. And then Microsoft has some guidelines for the types of collections to be used on public APIs. It suggests that you don't want to use weakly typed collections, that you want to use templated types of collections as opposed to just generic lists. And by generic lists, I don't mean system.collections.generic.list. I mean the actual list, like ArrayList, that does not have a particular type. They also suggest that you don't use ArrayList because it's weakly typed or a list of a templated type, and nor do they want you to use hash table or dictionary of templated types. And the reason is that those objects have a number of methods that they would prefer not be called from a public API, and they would prefer that that not be available, and that a lot of the methods are really for internal use. So that's their suggestion and guideline. Their suggestion is that you use iDictionary or iEnumerable instead of ArrayList or hash table or dictionary. They also suggest that you use collection and make that available as opposed to an array list or a list. So those are some general best practices. In future lessons, we're going to talk more specifically about exceptions.